So out of pharmaceutical engineering, we have seen size reduction, size separation, drying, evaporation, crystallization, distillation, then material construction, then establishment of industry. So out of pharmaceutical engineering, we already seen flow of fluid also, transportation of fluid also. So only 2-3 topics you can say they are remaining. So first one is a filtration, then second one is a mixing, and last one is a corrosion. So after these three topics, so corrosion वैसे भी वो चैप्टर इंपॉर्टेंट नहीं है corrosion, बट ये मिक्सिंग एंड फिल्ट्रेशन ये तो कंप्लीट होगा. corrosion अगर बाद में एट द एंड ऑफ सब सिलेबस होने के बाद में देखता हूँ तो उसमें कुछ है ही नहीं एक्चुअली. ओके, एंड आफ्टर इमीडिएटली आफ्टर द मिक्सिंग चैप्टर यू विल हैव टेस्ट टू टेस्ट फॉर द फार्मास्यूटिकल इंजीनियरिंग. तो आप तब तक अपना प्रीवियस के रिकॉर्डिंग्स देखना चालू करो, है ना. जिसका नहीं हुआ है वो देखना चालू करो रिकॉर्डिंग. डिफरेंस कुछ नहीं है, जो मैंने लिया है उनके लिए वही कंटेंट है आपके लिए, क्योंकि वो कंटेंट ऑलरेडी इम्प्रोवाइज है ना. तो जैसे अभी थर्ड बैच के लिए लूंगा तो ऑलरेडी कंटेंट इम्प्रोवाइज रहेगा उनके लिए अलग थोड़ी इम्प्रोवाइज करूँगा. बट पढ़ता हूँ मैं, टाइम टू टाइम पढ़ना भी इम्पोर्टेंट है. सो टुडे वी आर गोइंग टू सी द फिल्ट्रेशन चैप्टर. You can expect one or maximum 2 MCQs for the GPAT, as well as for the Niper you can expect 3 MCQs. So filtration chapter it might look very easy, but it is not. आपको लग रहा होगा कि filtration मतलब क्या होगा उसमें. filtration तो बहुत बार किया है हमने, बट कॉलेज का जो filtration होता है वो filtration थोड़ा सा यहाँ पे एग्जाम के पॉइंट ऑफ व्यू से अलग होता है. So you have a little bit difference. So you need to focus on the theory part. You need to focus on the different types of filters, their advantage, their disadvantage. Okay, construction working obviously not important. Working is not, construction is not important, but sometimes they may ask question from working. So I have compiled as much as I can. Okay, so everything is not possible at all. So filtration. So again it is one of the unit operation in the pharmacy. So as like your size reduction, size separation, so one of the unit operation in the field again is the filtration. So what do you mean by filtration? First, filtration. So what do you mean by filtration? So filtration is again a separation technique. So there are different separation techniques. जैसे separation के लिए आप size separation है, distillation होता है आपका, evaporation होता है, drying is also there. So drying, evaporation, distillation, size separation, these are known as the separation methods. Okay. So again filtration is also separation method. Filtration is also separation method. So you have to separate one component from mixture. So now in this mixture, so what kind of components are there? So you might have either uh, slurry or suspension. Now from that slurry or suspension you want to separate your solid. Filtration कब करते हो आप? जैसे आपने कोई रिएक्शन किया, रिएक्शन मिक्सचर हो गया आपके कॉलेज में, रिएक्शन करने के बाद में रिएक्शन मिक्सचर, तो आप उसको फिल्टर करते हो ताकि आप ड्राई प्रोडक्ट चाहिए. सो filtration is a nothing but the separation technique, and it is nothing but the separation of solid from fluid by passing the fluid through a porous medium that retains the solid but allows the liquid to pass on. Okay? So filtration is a separation technique, so separation of solid from fluid by passing the fluid from porous membrane that will retain a solid on a porous membrane and let liquid to be passed on. वो सस्पेंशन टू बी फिल्ट्रेटेड, जो फिल्ट्रेट करना चाह रहे हो आप, जिसका फिल्ट्रेशन करना है उसको क्या बोलेंगे आप? सस्पेंशन टू बी फिल्ट्रेटेड इज नोन एज अ slurry. Suspension to be filtrated is known as slurry. Okay, and medium used to retain the solid is known as a filtration medium. है ना, फिल्ट्रेशन medium. आप क्या करते हो फिल्ट्रेशन में? एक फनेल लेते हो, है ना, फनेल लेते हो, आपका जो भी रिएक्शन मिक्सचर है, फनेल लेते हो, फिल्टर पेपर लेते हो, फिल्टर पेपर में उसका कोन बनाते हो, फनेल में डालते हो, फिर वो सॉल्यूशन आप क्या करते हो उसमें डालते हो, इसमें फिल्टर पेपर में, और जो सॉलिड रहेगा वो फिल्टर पेपर के ऊपर रहेगा और जो लिक्विड रहेगा वो नीचे भी करने आएगा. दैट इज अ फिल्ट्रेशन. ओके, सो सेपरेशन ऑफ सॉलिड फ्रॉम फ्लूइड बाय पासिंग द फ्लूइड थ्रू ए पोरस मीडियम. इन दैट केस आप जो फिल्ट्रेशन करते हो उसमें पोरस मीडियम कौन है? That is a filter paper. So filter paper is a porous medium. So separation of solid from fluid by passing through a porous medium that retains the solid but allows the liquid to pass on, and suspension to be filtrated in this case is known as a slurry. Medium to be used to retain the solid component known as a filter medium, and the collected solid on the filter medium, जो solid filter medium के ऊपर बनता है उसको अपन बोलते हैं filter cake. उसको अपन बोलते हैं filter cake. That is known as a filter cake. Okay? So solid which is retained on the filtering medium is known as a filter cake, and the clear liquid which is passing through a filter medium is known as a filtrate. Is known as a, तो जो उसको फिल्टर करना है उसको क्या बोलना है भाई, स्लरी बोलना है उसको, है ना. जिसके ऊपर फिल्टर करना है उसको क्या बोलना है भाई, फिल्ट्रेशन मीडियम, है ना. फिल्टर मीडियम उसको बोलना है फिल्टर मीडियम. जिसके ऊपर फिल्टर कर रहे हैं आप जिसकी मदद से फिल्टर मीडियम, जो फिल्टर मीडियम के ऊपर जो सॉलिड बचा है उसको क्या बोलते हैं, केक बोलते हैं. तो केक मतलब ये खाने का हैप्पी बर्थडे वाला केक नहीं. ओके, देखिए क्लियर लिक्विड दैट इज पासिंग थ्रू फिल्टर इज नोन एज अ फिल्ट्रेट. जो नीचे बीकर में आता है उसको फिल्ट्रेट बोलते हैं. फिल्ट्रेशन इज द सेपरेशन टेक्निक. ओके, यू कैन से पार्शियल सेपरेशन टेक्निक. नाउ इफ द सॉलिड कंटेंट ऑफ योर स्लरी इज लेस देन 1%, अगर जो फिल्ट्रेशन करना है उसमें ही सॉलिड कितना है, 1% से कम है. इफ द सॉलिड कंटेंट ऑफ स्लरी टू बी फिल्ट्रेटेड, उसको स्लरी नहीं बोलेंगे अपन, उसको सॉल्यूशन बोलेंगे. If the solid content of solution to be filtrated is less than 1%, the process is known as a clarification. The process is known as a clarification. So there are two terms. First one is a filtration and second one is a clarification. Question इसके ऊपर आता है clarification. जैसे आपने कुछ गलत किया कॉलेज में, झगड़ा वगड़ा, तो आपको क्लैरिफाई करने के लिए बोलते हैं. यहाँ पे filtration means what? So filtration means removal of solid from liquid. Okay. Clarification means what? Again removal of solid from liquid. But in the filtration, solid content is high, more than 1%. More than 1%. कितनी भी हो सकता है, 30%, 40%. But clarification is the term. It is term applied when the slurry consists of or the solution to be filtered consists of a solid less than 1%. So it is known as a clarification. Am I audible to you? Are you getting? Okay. So first question यहाँ पे cover हो जाएगा clarification. So when the solid content is less than 1%, term is known as a clarification. Term clarification is used if the solution to be filtered consists of a solid less than 1% weight by value, known as a clarification. Other similar process like filtration, they are like a decoloration, decantation, then collation and expression. So these are the similar process: decoloration, decantation, collation and expression. ये भी क्या है, filtration के जैसे ही कुछ टेक्निक्स है. So for example, what do you mean by decantation? आप जो सुबह सुबह चाय पीते हो, चाय बना के चाय पत्ती डालते हो, दूध डालते हो, चीनी डालते हो, शुगर डालते हो, तो वैसे ही थोड़ी पीते हो. उसको उबालने के बाद में उसको उसको स्क्रीन करते हो, उसको छानते हो. So that is known as a decantation. एक्सप्रेशन मीन्स व्हाट? जैसे फॉर एग्जांपल ग्राउंड नट है, उसको अगर आप उसको प्रेशर डालेंगे उसके ऊपर तो उससे ऑयल निकलेगा, है ना. लेकिन उसमें ऑयल प्लस उसका रेसिड्यू रहेगा. बट अगर उसमें कोई स्क्रीन लगाए तो रेसिड्यू ऊपर रहेगा, ऑयल नीचे आएगा. नोन एज एक्सप्रेशन. सो फिल्ट्रेशन, क्लैरिफिकेशन, डीकोलोरेशन, डिकेंटेशन, कोलेशन, expression, these are the parallel terms. The filter medium, okay, the filter medium is nothing but the porous in nature. The pores of filter medium are smaller than the material. That is the prerequisite for filtration. Filtration कब होगा? जब filter medium के जो pores है, वो जो filter medium के pores है, the pores of filter medium they are smaller than material to be separated. तो suspension जो है आपका slurry, उसमें पार्टिकल साइज है से फॉर एग्जांपल, है ना, और आपका फिल्टर मीडियम का पोर साइज है 10 माइक्रोन. फिल्ट्रेशन कैसे होगा? पोर्स ऑफ फिल्टर मीडियम शुड बी स्मॉलर देन मटेरियल टू बी सेपरेटेड. तो जब फिल्टर मीडियम का पोर साइज होगा 2 माइक्रोन, 3 माइक्रोन, 2 माइक्रोन, तब जाके वो फिल्ट्रेशन होगा. सो दैट द 5 माइक्रोन पार्टिकल्स विल बी रिटेन ऑन द. So filtration is effected by the pressure differential. मैकेनिज्म क्या होता है, कैसे हुआ फिल्ट्रेशन? फिल्ट्रेशन इज अफेक्टेड बाय द प्रेशर डिफरेंशियल अक्रॉस द फिल्टर। आप बोलेंगे सर हमने फिल्ट्रेशन किया है ना, जो आपने बोला है फनेल में पेपर डाल के फिर फिल्ट्रेशन हो चुका है, वहाँ पे प्रेशर का क्या सवाल है? हमने तो प्रेशर यूज नहीं किया। You have not used pressure, but there is a pressure. Filtration is effected, means filtration is done by pressure differential across the filter. तो जो आपने फनेल के ऊपर जो स्लरी डाला है पेपर के फिल्टर पेपर में, तो उसका जो ऊपर प्रेशर है, द प्रेशर विच इज एक्सपीरियंस्ड बाय दैट स्लरी अबव द फिल्ट्रेशन मीडियम, मतलब फिल्टर पेपर के ऊपर जो है वो अलग प्रेशर एक्सपीरियंस करता है, और फिल्टर पेपर के नीचे मतलब you are collecting the filtrate, so at that place it is expressing different pressure. There is a pressure difference above the filter medium and below the filter medium, and this pressure differential is nothing but the driving force for, तो यही प्रेशर डिफरेंस होना चाहिए। अगर अगर फिल्ट्रेशन मीडियम के नीचे भी सेम प्रेशर है, ऊपर भी सेम प्रेशर है, so there will be no filtration, there will be no filtration, and that's why this technique is used to increase the filtration rate. So that's why sometimes you are using suction, means negative pressure below the filtration medium. Sometimes you are forcing the slurry to the filtration through the filtration medium. You are using pressure. So you are using positive pressure above the filter medium. You are using negative pressure below the filter medium to accelerate the filtration, to increase the filtration rate. Okay. Now after some time, ओके आफ्टर समटाइम जैसे आपने फिल्ट्रेशन चालू किया तो इमीडिएटली अगर फिल्ट्रेशन चालू किया पैनल में पेपर डाल के तो फटाफट फिल्टर होना चालू होता है, लेकिन कुछ टाइम के बाद फिल्ट्रेशन रेट स्लो होता है। सो आफ्टर सम टाइम रेजिस्टेंस ऑफर्ड बाय फिल्टर केक is high and filtration is reduced or later on it is stopped, because जैसे जैसे वो फिल्टर पेपर के ऊपर आपका सॉलिड डिपॉजिट होना चालू होता है, जितना ज़्यादा सॉलिड डिपॉजिट होगा उतना फिल्ट्रेशन रेट कम होगा। So again, filtration rate is inversely proportional to the क्या बोलेंगे size of cake or the uh, diameter of cake. Okay, so जैसे solid डिपॉजिट होगा वैसे वैसे आपका filtration rate कम होगा। Okay? So positive pressure on cake, it is known as the upstream pressure. Positive pressure on cake upstream, or that is known as upstream pressure, and negative pressure below the filter medium, that is known as a vacuum, that is applied it known as a downstream. So if you want to increase the filtration rate आपको बढ़ाना है तो आपको एक तो ऊपर से प्रेशर डालना पड़ेगा, मतलब you have to use pressure to force the solution or slurry under filtration through a medium, then only filtration rate will be increased. Or you can alternatively you can decrease the pressure below the filtration medium, मतलब आप जो फनेल होता है आप देखो सक्शन से फिल्ट्रेशन करने के लिए क्या करते हो, स्लरी डालते हो फिल्टर पेपर के ऊपर और वो सक्शन चालू करते हो, सक्शन नीचे फनेल में लगा होता है, वो नेगेटिव प्रेशर क्रिएट करता है एंड फटाक से आपको फिल्ट्रेशन हो जाता है। जो फिल्ट्रेशन आपका 1 आवर लगता है नॉर्मली ग्रेविटेशनल, मतलब नॉर्मल इफ यू वांट टू फिल्टर समथिंग नॉर्मल एनवायरनमेंट it will take a longer time. If you use suction, it will filtration will be completed within a fraction of second. Now this is a filtration. Okay, so you can increase the filtration rate by applying a pressure upstream pressure, that is a pressure above the filtration medium, or you can decrease the pressure below the filter medium downstream, that is negative pressure. So again, what are the applications of filtration? अपनी filtration देख रहे हैं क्या उसका यूज क्या है। So okay, applications of filtration, lot of applications are there. You know that you want to purify the compound, you want to separate the compound, वो सब आपके सेशनल एग्जाम के लिए है। So for example, filtration is applicable in the production of sterile product. So production of sterile product, for example, in the sterile product manufacturing, in the parental products, you need a air, air should be air should be sterile air, वहाँ पे आपको जो हवा लग रहा है वो भी sterile होना चाहिए। So for the production of sterile air, HEPA filters or laminar laminar air bench. HEPA filters means what? High efficiency particulate air, high efficiency particulate air, तो इसका पार्टिकल काउंट भी आपको मालूम हो कितना पार्टिकल्स अंदर है। हाई एफिशिएंसी पार्टिकुलेट एयर फिल्टर, HEPA filters or laminar air bench, they are used in the industry to produce a sterile air. Again, bacteria proof filter will give you sterile solution. So in the there is one method known as sterilization by filtration. Sterilization by filtration. Sterilization मतलब क्या है? Absence of any viable form of bacteria. Any viable form of microorganism. कोई भी जिंदा माइक्रोऑर्गेनिज्म है तो वो स्टराइल नहीं है. So solution, if you want to make a solution sterile, there are different way for sterilization. One of the method is nothing but the bacteria-proof filtration. Filtration using bacteria-proof filter to get a sterile solution. Again, filtration is also involved in the, or it is also applicable in the production of bulk drug production. Separation of solid in the finish reaction. Reaction is completed, and you have to separate the solid. Again, filtration is also used for the removing of impurities. Impurity remove करने के लिए भी filter. So filtration is applicable for the production of bulk drug, for the production of for the removal of impurities. Production of liquid orals, okay, oral liquids. So filtration is important step for getting a clear solution. अगर आपको oral liquid oral syrup बनाना है, clear बनाना है, say for example elixirs, okay. So if you want to produce the elixir, clear elixirs or aromatic waters, so you need a filtration to remove the solid content. Then aromatic waters, they are also prepared by filtration, syrups, elixirs, eye drops. Clarification of water, clear water चाहिए आपको, so filtration is equal. This is the application of filtration. Are you getting or not? समझ रहे हैं आपको filtration, application of filtration. What is filtration exactly? So this is, say for example, this is known as a filtration medium. Filter medium is filter medium or filter media. Then this one is funnel. So whatever slurry or whatever solution you want to filter, placing over here. You are collecting, if you want to collect, if you are collecting filtrate in the beaker, यहाँ से okay, filter medium. So this is a porous. So what will happen? There is a retention of solid over here and liquid will pass on filtrate. This is the filtration assembly on a laboratory scale. So you are doing filtration at a laboratory scale by using funnel, and sometimes you are also using vacuum. यहाँ पे vacuum भी use कर रहे हो, suction pump. So okay, types of filtration. There are two type of filtration. Screen filtration and depth filtration. Screen filtration and depth. So suppose आपने यहाँ पे filter paper use किया है, या फिर आपने यहाँ पे instead of filter paper आपने केसलगर powder use किया है. So initially the screen filtration होता है. The filter paper use किया तो there is a screen filtration. मतलब आपका filter media का particle size pore size रहेगा एक particular, और आपका solid जो है content. So if it is more than size of pores of filter medium, so they will be written and liquid will pass on. It is known as screen filtration. Second one is known as a depth filtration. What do you mean by depth filtration? Suppose you are using any filter media and filter aid. So at that time, so say for example talc powder, keselgar. Okay? So at that time, so there is no direct pores. There is no pores. There is what? There is a capillaries. So liquid will pass through capillaries, not the pores. Because okay, if you are using filter medium and after that, after some time of filtration, after initial period is gone. Say for example 10-15 मिनट के बाद में कुछ solid deposit होगा, है ना? So और filter medium भी अपने filter aid भी use किया. So what will happen? So at that time there is a no pores, but there is a capillaries. So through these capillaries, liquid will pass on, and solid particle will return on this. Okay? This is known as a depth filtration. So initially screen filtration is there, and after that depth filtration. Now what is that? Separation of solid. What is filtration? So separation of solid by passing, okay, separation of solid fluid or solution by passing through porous medium that will retain a solid but allows the liquid to pass on. When solid content is less than 1%, the clarification is the term. Clarification is high. Okay, so we have seen HEPA filters are used to produce sterile air. Laminar air bench are used to produce the sterile air in the parental product area. Mechanism of filtration. So for mechanism, there are 3-4 mechanisms. So straining, first one is straining, then impingement, then entanglement, and attractive. So these are the you can say these filtration is affected by these things. Filtration कैसे होता है? Because of these things. Straining मतलब क्या? It is just simple as the sieving. आप जो सुबह सुबह चाय बनाने के बाद में जो उसका सेपरेशन करते हो, है ना, चाय पत्ती आप सेपरेट करते हो फ्रॉम द टी, वो टी लिक्विड, तो लिक्विड टी से आप चाय पत्ती सेपरेट करते हो, so that is nothing but the staining. So similar to sieving, large size particle cannot pass through the smaller filter medium. There is known as staining. Second होता है impingement. So solid having momentum move along with the path of streamline flow and strike or impact to the impact to the filter medium. मतलब क्या कि जो लिक्विड जो सॉल्यूशन सस्पेंशन में सॉलिड है, they will free they will move a mean free path. They are having momentum move along with the path of streamline flow. So, in this case they consider the filtration is like a laminar flow, and during that flow जो सॉलिड है वो स्टिक होगा, इम्पाइक होगा, इंटेंगल होगा इसमें फिल्टर मीडियम. Then entanglement, particle will become entangled in the mass of fibers or cloth of very fine airy surface, है ना. अब देखो घर वाले आजी आजोबा वगैरह जो दादा दादी वो कैसे फिल्टर करते थे, एक कपड़ा लेते थे, कपड़े में वो लगाते थे और उसको स्क्वीज करते थे ताकि लिक्विड जैसे हनी, पुराने ज़माने में जब हनी मतलब आजकल तो बॉटल में आता है मेडिकल में, पुराने ज़माने में पेड़ में जो हनी कॉम्ब है उससे उसको निकालने पड़ते, ठीक है. तो उसमें कुछ भी कंटेमिनेशन ना आए, मतलब कुछ भी सॉलिड पार्टिकल ना आए या मिट्टी ना आए या फिर कोई रेसिड्यू ना आए, कोई पार्ट ना आए प्लांट का, तो वो सब वो पूरा हनी कॉम्ब लेके एक क्लॉथ में ले लेते, जैसे आपका मसलिन क्लॉथ हो गया है या फिर जैसे आपका है ना धोती का कपड़ा हो गया उसमें, और उसको स्क्वीज करते थे ताकि लिक्विड नीचे आए और वो सॉलिड अटक. So that is known as entanglement. And attractive forces solid are written on the filter medium as a result of attractive forces between particle of the filter medium and particle solid particles. तो जो फिल्टर मीडियम यूज कर रहे हैं आप, जैसे से फॉर एग्जांपल फिल्टर पेपर, उसमें फाइबर्स रहेगा, फिल्टर पेपर इज मेड ऑफ सेलुलोज, उसमें फाइबर्स रहता है, उसमें भी इलेक्ट्रोस्टैटिक चार्ज होता है, attractive force होता है. Suppose talc powder, केसलगर, resin powder, so that will also cause attractive force. So the force of attraction between solid particles and particles of filtration medium, that is known as the attractive force. So mechanism is okay. Filtration is effected by these things, either staining, impingement, entanglement, attractive forces. Okay. Now there are two type of filtration, okay, as I told you, surface filtration or screen filtration. Surface filtration is also known as a screen filtration, okay, and depth filtration is known as a okay, depth filtration mostly used for the clarification, and cake filtration is also. So types of filtration ये तीन है, ठीक है, जैसे मैंने बोला है आपको. Now difference between surface filtration and depth filtration. Surface filtration और depth filtration में difference क्या है? So size retained on the particles is slightly higher than mean pore size of the medium. Surface filtration में क्या हो रहा है कि जैसे आपका फिल्टर पेपर है, फिल्टर पेपर में पोर साइज है वो कुछ, तो उससे ज़्यादा साइज वाले सॉलिड पार्टिकल ऊपर रहेंगे, मतलब अटक जाएंगे, बाकी सब नीचे जाएंगे. साइज ऑफ रिटेन सॉलिड इज स्लाइटली हायर देन दैट ऑफ द मीन पोर साइज ऑफ द. डेप्थ फिल्ट्रेशन में क्या होता है, साइज ऑफ द पार्टिकल which are retained they are much smaller than the pore through which the fluid is passing. क्योंकि इसमें क्या होता है, उसमें एक तो फिल्टर मीडियम का भी पार्टिकल्स है, उसमें आपके जो पार्टिकल्स है सस्पेंशन के वो भी कुछ एक फॉर्म हो चुका है ऊपर, एंड वहाँ पे सिर्फ अभी पोर्स नहीं दिख रहे, सिर्फ कैपिलरीज हैं. So size of particle retain is much smaller than the pore through which they are passing in depth filtration. Okay. Then surface filtration strength, okay, is less except intermediate is made from stainless steel. Strength is less, मतलब अगर आप फिल्टर पेपर यूज करें तो उसमें स्ट्रेंथ कम है. ओके. Strength is less except filtration medium is made from stainless steel. तो stainless steel का है उसमें तो स्ट्रेंथ रहेगा, अदरवाइज नहीं. And surface filtration also has a low capacity. but in case of depth filtration, mechanical strength is high and capacity is also high. अभी intermediate नहीं है, अभी filtration medium है. Particle size obtained in the surface filtration. Particle size written on the particle is more predictable. So during the surface filtration, you can predict the particle size of retained particles. Particle size of retained particles or solid is less predictable. Okay. Then equipment used in the surface filtration is expensive. Equipment used for the depth filtration, they are cheaper and no auxiliary equipment are required. Okay. Surface filtration में क्या auxiliary equipment जैसे एज लगेगा, क्लैंप्स लगेंगे उसमें. For example, cellulose membrane filters. Cellulose membrane filters are the example of surface filtration or screen filtration. Then ceramic filters and sintered bed filters are the example of depth filters. Difference है, बुक में भी है, CBS सुब्रमण्यम में, फार्मास्यूटिकल इंजीनियरिंग बाय CBS सुब्रमण्यम, उसमें भी ये दिया है. So theory of filtration, theory of filtration, theory of filtration. So remember there are three theories. So Poiseuille's equation, then Darcy's theory or Darcy's equation, and Kozny-Karaman theory or Kozny-Karaman equation. तो ये जो इक्वेशन है उसके ऊपर क्वेश्चन आया है GPAT 2023 में, Kozny-Karaman equation के ऊपर. So we'll see it first. We'll see this slide. Theory of filtration. So what is filtration? You know that we have seen separation of solid from slurry with the use of filtration medium. Now filtration rate, rate of filtration or filtration rate means, filtration rate means what is filtration rate? So filtration rate means the filtrate formed per unit time, per unit volume. What is the filtration rate? So filtration rate is given by driving force divided by resistance. Driving force क्या है? The pressure differential. Filtration rate is equal to driving force divided by resistance. पहले driving force क्या है? So pressure differential. Then resistance क्या है? Resistance is nothing but the filter medium and the cake formed on the filter medium. That is the resistance. Driving force divided by resistance is equal to filtration rate. Okay? Resistance to the movement or filtration. Okay. So देखा, upstream pressure minus downstream pressure. That is known as a pressure differential. That is driving force and length of capillaries in case of depth filtration. So filtration rate is given by driving force divided by resistance. पहला आता है Poiseuille's equation. Poiseuille's equation. So it is likewise that V is equal to pi into delta PR raised to 4 divided by 8 L into micro. तो यहाँ पे V क्या है? Rate of flow. Rate of flow is flow rate of liquid through a filtration medium. So rate of flow, delta P is nothing but the pressure differential across the bed. R is the radius of capillary in the filter bed. L is the thickness of cake builder, and micro is the viscosity. Now what Poiseuille's equation say? Poiseuille is considered that the filtration is similar to the laminar flow of fluid. The laminar flow of fluid देखा है अपन ने, turbulent देखा है. तो Poiseuille ने consider किया कि filtration is also like that a laminar flow of liquid. मतलब flow will liquid will move in a streamline flow. Okay, liquid under pressure through capillaries. So he considered the filtration is similar to the laminar flow of liquid under the pressure through capillaries. If cake is made of bulk mass of particle, जो filtration के समय cake बनेगा, so it is made of bulk mass of particles and liquid flowing through interstices. Interstices मतलब equal to multiply by length of capillary. जो capillaries बनेगी उसका length. In this case, flow of liquid through these is expressed by Poiseuille's equation. Poiseuille's equation क्या है आपने देखा है. आपको इतना याद नहीं रखना है, आपको सिर्फ इतना याद रखना है कि Poiseuille's equation is related with the filtration बस. Then आता है Darcy's equation. Darcy equation Poiseuille's ने कंसिडर करके इक्वेशन बनाया रेट ऑफ फिल्ट्रेशन. क्या कि जो फिल्टर में फ्लो ऑफ liquid through filter medium is exactly like a streamline flow. Okay, वो कंसिडर कि Poiseuille's ने ये इक्वेशन बनाया. Darcy's equation. Darcy's equation is V is equal to, that is a filtration rate is equal to Ka delta P divided by micro L. What is K? K is the permeability coefficient of a cake. Cake से कितना permeability हो रहा है? Okay, meter square. A is nothing but the surface area of porous bed in meter square. Other terms are similar like a Poiseuille's equation. Micro L, P मतलब pressure differential, micro मतलब viscosity, and L मतलब length, thickness of cake. देखो Darcy Poiseuille's equation assumes that the capillaries in the filter are highly irregular and regular, very irregular, and non-uniform. Poiseuille's law assumes that the capillaries in the filter are highly irregular and non-uniform. If the length of capillaries is taken as a thickness the bed, then अगर लेंथ कैपिलरी का जो है वो एज अ थिकनेस ऑफ बेड कंसिडर करेंगे तो करेक्शन फैक्टर लगता है यहाँ पे. Correction factor for radius is applicable so that the rate of filtration equation is closely and simplified by Darcy. The Darcy ने ये सिंप्लीफाई करके फिर बोला है कि जो कैपिलरीज है, जो पॉइजलीज ने बोला है कि लैमिनार फ्लो जैसे फ्लो होता है लिक्विड का थ्रू फिल्टर मीडियम, उन्हें इसने बोला है कि नो. So there are capillaries in the during the when there is a development of cake. So there are capillaries. So that the capillaries they are irregular होता है and non-uniform होता है. And if the length of capillaries is taken as a thickness the bed, अगर लेंथ ही आपको कंसिडर करना है तो आपको करेक्शन फैक्टर देना पड़ेगा फॉर द रेडियस. And now he modified the equation created by Poiseuille's. Now that is known as a Darcy's equation. And we have seen that. So permeability terms they were imported by Darcy. Permeability coefficient इसने import किया, इसने Darcy ने. ठीक है, आपको सिर्फ समझ लो, आपको सिर्फ बाकी इतना याद रखना है कि कौन सा इक्वेशन किससे रिलेटेड और इक्वेशन के ऊपर क्वेश्चन आ चुका. देन लास्ट में आता है आपका कोजनी-कैरमन इक्वेशन. So Kozni-Kärman equation is equal to A divided by NS square into delta P divided by KL into epsilon cube divided by 1 minus epsilon square. What is epsilon? Porosity of K. What is S? Specific surface area of particles. K is nothing but the Kozni constant. Other terms are similar to Poiseuille's equation. Kozni-Kärman equation, Poiseuille's equation is not applicable for the porous bed. Poiseuille's equation किसके लिए applicable है? It is only applicable for the surface filtration, not for porous bed. By including the additional parameters the resultant equation which is most commonly used for the calculating the rate of filtration, that is the Poiseuille's equation. Sorry, that is the Kozni-Kärman equation. तो याद रखना है यहाँ पे most commonly used equation for calculation of filtration rate is a Kozni-Kärman equation. उसका limitation क्या होता है? So the fact that depth of granular bed is less than actual path transversed by fluid which is not taken into consideration. Actual path is not a straight, it is a tortuous. तो ये आपको याद रखना है कि there are three equations of theory related to filtration. Okay, first one is a Poiseuille's equation, second one is a Darcy's equation, and third one is a Kozni-Kärman equation. We have seen these three equations. I will repeat again. So filtration rate मतलब क्या है? So amount of slurry filtered per unit time, that is known as a filtration rate. Now it is given by driving force divided by resistance. Driving force क्या होता है? Pressure differential. Resistance क्या होता है? Okay, resistance offered by filtration medium or the length of cake, and resistance to the movement is upstream pressure minus downstream pressure divided by length of capillary. सबसे पहले Poiseuille's equation आता है. Poiseuille's considered the equation V is equal to filtration rate is equal to delta pi into delta PR square divided by 8 L into micro. What is V? Rate of flow of liquid through the filtration medium. Delta P is the pressure differential across the bed. R is the radius of capillaries. L is the thickness of building cake. जो केक बन रहा है फिल्टर मीडियम के ऊपर उसका viscosity of filtrate is micro. Now डार्सी ने ऑब्जर्व किया कि पॉइजलिस ने बोला जो है, पॉइजलिस ने इक्वेशन दिया बाय कंसीडरिंग दैट फ्लो of flow of milk. Okay, so flow of liquid in during filtration is exactly like a streamlined flow of fluid. इसने कंसिडर किया, बट इसने बोला है कि नहीं. सो कैपिलरीज जो होता है केक फॉर्मेशन के बाद में, केक बना है उसके ऊपर, बाद में कैपिलरीज आएगा, वहाँ पे कैपिलरी टर्म आएगा. कैपिलरीज का अगर आपने लेंथ लिया तो उसमें रेडियस भी कंसिडर करना पड़ेगा. उसने ये इक्वेशन दे दी. So V is equal to K delta P divided by microliter. K is nothing but the permeability coefficient of the cake. K is the surface area of porous bed, and other terms are similar to that. Therefore, Poiseuille's law. Poiseuille he considered that the filtration is similar to laminar flow under the liquid under pressure. Liquid under pressure through capillaries. If the cake is made up of a bulk mass of particle, liquid flowing through interstices is equal to the length of capillary tube. In this case, the flow of liquid through these are expressed. Darcy ने क्या बोला? Poiseuille's equation assumes that the capillary in the filter are irregular. Okay, Poiseuille's law assumes that the capillaries in the filter are highly regular, but Darcy observed that it is irregular and non-uniform. So if the length of capillary is taken as a thickness of the bed, then correction factor, that is the radius, is required, and he modified the equation known as the Darcy's equation. We are seeing the equation that is a V is equal to Ka delta P microliter, okay, divided by micro and E. The next Kozny-Karaman equation होता है. So he given the another equation by modifying or by imparting the other vectors. Right? Is equal to A divided by Ns square into delta P divided by Kl into epsilon cube divided by 1 minus epsilon square. Epsilon क्या होता है? Porosity of cake. K is the specific surface area of particle and K is the Kozny-Karaman constant. The Poiseuille's equation is applicable to not applicable to porous. It is applicable to porous bed by including the additional parameters. Okay. By adding the another parameters, Kozny-Karaman, resultant equation is known as the Kozny-Karaman equation, which is most commonly used for bed. इसका एक limitation होता है. In fact, the depth of granular bed is less than actual path traversed by fluid. जो depth होता है वो कम है than actual path completed by fluid from the slurry to the filtration medium, and it is not taken into consideration. The actual path is not straight; it is a tortuous. तो ये straight ऐसा filter नहीं हो रहा है straight लेकिन तो जब cake build होता है तो थोड़ा सा ये porous होते हैं वैसे actual path is tortuous. So modifying this equation again, he given the another equation known as the Kozny-Karaman equation. आपको आपका इम्पोर्टेंट क्या है कि आपको बस तीन चीज याद रखना है. कौन से तीन चीज? सो देयर आर 3 इक्वेशंस रिलेटेड टू फिल्ट्रेशन. क्वेश्चन आज इस बार आ चुका है. Kozny-Karaman equation is related with the following unit operations: Kozny-Karaman equation, Darcy equation, and Poiseuille's equation. They are related with the filtration. क्वेश्चन ऐसा भी आया था और एक क्वेश्चन आया था रेट ऑफ फिल्ट्रेशन इज गिवन बाय फॉलोइंग इक्वेशन. एक बार ऐसा भी क्वेश्चन आया डार्सीज इक्वेशन इज रिलेटेड विद डार्सी इक्वेशन फिल्ट्रेशन. पॉइज़ुइलेज इक्वेशन ये फ्लो ऑफ फ्लूइड में भी आता है. कोज़नी-कैरामन इक्वेशन. आपको बस आपके काम का क्या है इतना है. इफ यू वांट टू रीड मोर यू कैन रीड फ्रॉम द बुक आल्सो. सेम थिंग इज गिवन इन द बुक. वही से तो एक्स्ट्रा किया. सो यू आर यूजिंग ए मैकेनिकल you are using a tough mechanical some material having mechanical strength known as a filtration medium. Filtration medium. Now filter media is nothing but the actually filter media is nothing but the material which is a porous on which solid will be retained. Okay. Now this filter media is enclosed in the device which is having mechanical strength known as a filter medium. So what are the examples of filter media? Filter medium. So woven material such as felt, woven material such as felt or cloth. आपका जो सिंपल क्लॉथ होता है उससे भी फिल्ट्रेशन होता है. परफोरेटेड शीट मेटल और परफोरेटेड बेड और बेड ऑफ ग्रेनुलर सॉलिड. filter on a separating medium. Then prefabricated porous solid unit, membrane filter media, silver strips cartridges and depth type of cartridges. These are known as a filter media. फिल्टर मीडिया कौन है, फिल्टर मीडिया कौन है याद रखना है आपको, और बाद में फिल्टर एड कौन है वो याद रखना है क्योंकि क्वेश्चन उसके ऊपर आ चुका है। फेल्ट और क्लॉथ, परफोरेटेड शीट ऑफ मेटल और बेड ऑफ granular solid buildup on a separating medium or prefabricated porous solid unit, membrane filter media, silver strip cartridge and depth type of cartridge. These are the filter media. Now, what is meant by filter aid? What is meant by filter aid? So filter aid means these are the, again they are used mostly for clarification purpose. Filter aid जो होता है वो mostly clarification के लिए use होता है and it is used in the 1% only, less than 1%. Okay? So it is mixed with the your slurry to be filtrated and then filtration is effected. Filter aid का example होता है केसलगर, talc, charcoal, asbestos, paper pulp, bentonite, fuller's earth. Important है, the main purpose of filter aid to prevent the medium from blocking and to form a open porous cake and reducing the resistance to the flow of filtrate. तो main aim क्या होता है filter aid का, इसके ऊपर भी क्वेश्चन आ चुका है. What is the main aim of filter aid? The to prevent the medium from blocking to form a open porous cake and by reducing the resistance to the flow of filtrate. तो फिल्टर एड एग्जांपल क्या क्या है अपने देखा है, केसलगर, टाल्क, पेपर पल्प, फुलर्स अर्थ. क्वेश्चन एक बार ऐसा है, वन ऑफ द फॉलोइंग इज नॉट अ फिल्टर एड, वन ऑफ द फॉलोइंग इज नॉट अ फिल्टर एड. तो आपको इसका एग्जांपल याद रखना है, केसलगर, टाल्क, चारकोल, एस्बेस्टॉस, पेपर पल्प एंड फुलर्स अर्थ. दे आर ओनली they are used less than 1%, 0 to 1% उसको यूज करते हैं, मतलब 0.1 maximum 1%. Now this maximum 1% filter aid is mixed with the solution or slurry to be filtrated. Okay, and they are used to prevent the medium from filter medium from blocking and to form a open porous cake, which will help to reduce the resistance of flow. Now activated charcoal, it is a filter aid mostly used to remove the impurity. Activated charcoal impurity में remove, क्योंकि ड्यूरिंग फिल्ट्रेशन जो एक्टिवेटेड चार्कोल का आप जो पाउडर यूज कर रहे हो वहाँ क्या होगा, इम्प्योरिटीज जो है वो इम्प्योरिटीज उसको एडियर होगी, उसको ना फिजिकल बाय इट्स फिजिकल एक्शन. देन फिल्ट्रेशन, केसलगर 0.1% is added to a slurry to be filtrated. Filtration reduces the 5 times or more. मतलब फिल्ट्रेशन रेट जो है ना वो इंक्रीज होता है 5 times or more. तो फिल्टर एड से इसके ऊपर क्वेश्चन आ चुका है. सो रिमेंबर केसलगर when it is used as a filter aid, it is a 0.1% is added to a slurry to filtrate. Filtration rate जो है वो 5 times or more. Filter aids are mostly used for the clarification. यहाँ पे क्या था, filter aids mostly used for the clarification. Equipment depending upon the application and the reactional force. So types of filter based upon the application of reactional force. Filter pressure filters होते हैं, एग्जाम्पल होता है उसका प्लेट एंड फ्रेम फिल्टर प्रेस. मेटा फिल्टर्स, इसके ऊपर भी एक बार क्वेश्चन आया. मेटा फिल्टर्स दे आर द प्रेशर फिल्टर्स. वैक्यूम फिल्टर्स का एग्जांपल है फिल्टर लीक. सेंट्रीफ्यूगल फिल्टर्स का एग्जांपल बुक में भी नहीं दिया है. सो फैक्टर्स अफेक्टिंग ऑन फिल्ट्रेशन. सो आई थिंक बाकी जो है ना अपन कल देखेंगे.